We'll now look at a process to actually solve systems of equations. So first we'll walk through the idea. We have to start by identifying the first non-zero column, and then we want to get a 1 in the first row of this column. After that, we want to get a 0 in all of the other entries in the column. We're then going to move to the next non-zero column and get a 1 in the second row. And then we want to get a 0 for all the other entries. And we're going to continue this. Go to the next non-zero column, get a 1 in the third row, zeros everywhere else, etc. So let's do some examples. We'll start with a small case, 2 equations with 2 variables. So we're going to start by putting this in augmented matrix form. This is -4, -8, 80, 9, -5, 73. So the first step is to get a 1 in this first non-zero column, which in this case is just the first column. And whenever we want to get a 1, we're going to do one of 2 things. Most of the time, we're going to use our scaling operation, the one that says we can multiply a row by a non-zero constant. In this case, I'm going to multiply the first row by -1/4. And this is our shorthand, -1/4 R1. -4 times -1/4 is 1. -8 times -1/4 is 2. And 80 times -1/4 is -20. My second row I didn't actually change, so we'll leave that the same. And then we'll go to the next step, which said to get a 0 in all other entries in that column. Well, there's only a 1, and it's currently a 9. When we're working on zeros, we're going to use the first operation. In this case, I want to get a 0, so I need to add a multiple of the first row to the second to make it 0. So I'm going to add -9. Row 1 plus row 2, because -9 times 1 is -9, plus 9 is 0. -9 times 2 is -18, minus 5 is -23. And -9 times -20 is 180, plus 73 is 253. Next, we move to the second column and we get a 1 in the second row. Once again, we're going to do this with our scaling operation. In this case, I'm going to multiply the second row by -1/23. That gives me a 0, a 1, and a -11. And I didn't change the first row. We now get a 0 in all other entries in that row, or in that column. So we're not going to change the second row, only the first. And in this case, I need to get rid of a 2, so we'll do -2 row 2 plus row 1. -2 times 0 is 0, plus 1 is the 1. -2 times 1 is -2, plus 2 is 0. And then -2 times -11 is 22, minus 20 is 2. So this gives us a solution of 2, -11. This time we'll do a little bit of a bigger example, a 3 by 3. And the idea is the same, we're just going to have more steps. So we start with the augmented matrix. 1, -8, -2, -6, 3, 5. -4, -1, -6. And then we have a 70, -95, and a 21. So the first step is to get a 1 in the first row, first column. And we already have that. So we can skip to the second step, which says to get zeros everywhere else. So I'm going to start with getting the 0 in the second row. It's currently a -8, so we need to add 8. 8 row 1 plus row 2. Because 1 times 8 is 8, minus 8 is 0. 8 times negative 6 plus 3 is negative 45. 8 times negative 4 minus 1 is negative 33. And 8 times 70 minus 95 is 465. I also want to get a 0 in the third row. In this case, it's currently a negative 2, so I need to add 2 to make that a 0. So 2 row 1 plus row 3. 2 times 1 is 2, minus 2 is 0. 2 times negative 6 plus 5 is negative 7. 2 times negative 4 minus 6 is negative 14. And 2 times 70 plus 21 is 161. So our next step is to get a 1 in the second row, second column. So in this case, I'm going to start by leaving my first and third rows. Actually, no. I'm going to leave my first row alone. So in the past, whenever we wanted to get a 1, we multiply by the reciprocal, in this case, negative 1 over 45, but you'll notice that'll introduce fractions, and maybe we don't want to do that. So instead, I'm going to switch the second and third rows. So this is now 0, 7, minus 14, 161, and 0, negative 45, negative 33, 465. Now I can multiply by negative 1 over 7 times the second row. My first and third rows will stay the same in this case. And then my second row will change. In particular, to 0, 1, 2, and negative 23. Next, we need to get zeros in all other entries in that column. So, what we had before was 1, negative 6, negative 4, 70. 0, 1, 2, negative 23. 0, minus 45, minus 33, and 465. So we'll use our row operations. In this case, my second row will stay the same, so we can go ahead and write it. And we'll be changing the first and third row. In particular, the first has a negative 6 in the spot we want to turn a 0. So I'm going to do 6 times the second row plus the first. 6 times 0 plus 1 is 1. 6 times 1 minus 6 is 0. 6 times 2 minus 4 is 8. And 6 times negative 23 plus 70 is minus 68. The third row has a negative 45, so we'll do 45R2 plus R3. 45 times 0 plus 0 is 0. 45 times 1 minus 45 is 0. 45 times 2 minus 33 is 57. And 45 times negative 23 plus 465 is negative 570. Finally, we want a 1 in the third row, third column. In order to do this, we're going to leave the first and second rows alone. And we'll multiply the third row by 1 over 57. That'll give us a 0, 0, 1, and negative 10. Finally, we want to get a 1 or a 0 in all other entries in that column. In order to do this, we'll have to do a negative 8, row 3 plus row 1, That would give us a 1, a 0, and a 0. And then negative 8 times negative 10 minus 68 is 12. We also need to do a negative 10 row 3 plus row 2. And here we'd have a 0, a 1, a 0, and then negative 2 times negative 10 minus 23 is negative 3. So our solution is 12, negative 3, negative 10.